What up? Hey, let's do a little, in my opinion, I'm gonna give you a little how, a little when to use the quotient rule. Take it or leave it. Let's go. I did the proof in the last one, but here's our formulas. Clearly, right? Clearly. Leave the bottom alone, take the derivative of the top, minus leave the top alone, take the derivative of the bottom, and square the bottom. Yeah? Clearly, you got that thing, huh? You know what I mean? Same thing down here, just written in a different notation. Leave the bottom alone and multiply by the derivative of the top. Then you need to subtract out, leave the top alone, now take a derivative of the bottom, and then you just square the bottom. I'm not going to sing it, but I had a teacher do a little sing-song thing, and it's literally how I remember how to do it. Like these formulas, I know them and I can derive them and all, but that's not how I memorize them. I'm going to do it with this little sing-song thing. So G is down low, F is up high. F is up high. So I'm just going to write it as high over low. Know what I mean? High and low. What's up high? What's down low? Now, D means derivative, okay? So here we go. Low D high, high D low, square the bottom, away we go. Low D high, high D low, square the bottom, away we go. All I need to remember when to get this down is low D high. Because unlike the product rule, you can't turn this shit around. There's a minus sign in the center. Product rule, you can be sloppy. Quotient rule, you can't. You'll get the wrong sign. So the little sing-song thing is low times the derivative of high. Why did I write like that? Why did I write like that? Times the derivative of high minus high times the derivative of low. And then you just square the bottom. Low D high, high D low, square the bottom, away we go. No, that's how I keep it straight. Take it or leave it. So here we go. Now we'll start using it. So for this, I'll jump aside just for now and say like our f, or our f of x, is equal to 4 minus 3x is what's up top. And then our g of x is going to be 3x squared plus x. So let's go get our derivatives real quick. Got prime of x, so that's just negative 3, and then our g prime, the shit on the bottom. What's that? 6x plus 1. Cool, now we just follow the formula. Just follow the formula. Look, it's right there. You can either use my low D high, like F is high, G is low, or you can use the formula. So now we can say that our y prime is going to be, let's write it out, low, or, see, I just do low. Low is 3x squared plus x. D high, derivative of high, that's negative 3. Minus high, that's 4 minus 3x. Times the derivative of low, and what was that? We got that off on the side, 6x plus 1. All over, square the bottom. So there's a derivative. It is not cleaned up. That is not at all cleaned up. So what we need to do on this is leave your denominator factored, unless you're asked to take a second derivative. Unless you're asked to take a second derivative, you're going to want to leave that thing factored. So you don't want to expand that out, but it's the numerator. Because things might cancel out, they might clean up, stuff could happen. And I like problems that clean up. Sometimes, I don't know. So let's mess with some algebra. So we're going to get negative 9x squared minus 3x. And now I've got to be careful here. This is this algebra, dude. It's not necessarily the calculus that's going to get us. So 24x plus 4 minus 18x minus 3x. Notice I use that parenthesis there because I really don't want to commit sign error. And I've never done this problem before, so I don't know if anything cool is going to come of this. So let's just keep on grinding through it. So let's remove those parentheses. Maybe we'll do 2 steps in one. 24x minus 18x. Whoa, wait a second. Something wonky happened. There's a square here. There it is. Probably screaming, Dad, squared! Sorry. So that negative is going to come in a positive this one. So we're going to get positive 18x squared. Now let's put these two together. 24x minus 3x, that's 21x. And then we're going to change the sign. Minus 21x. And then we'll change the sign to that 4 to a negative 4. Okay, let's keep going. Let's see what happens. Once we start combining our like terms, we get 9x squared minus 18x minus 4 all over 3x squared plus x all squared. Well, yeah, it looks like our numerator is good enough. I don't think that's going to factor out. I just wanted to check and make sure. Because what if it did and it canceled? We could make it cleaner. So there you be. Just clean up that numerator. Expand it out. See if it can't factor. I don't see a quick simple factor. I noticed something just popped up on the other side. I paused for a second just to check and see. I'm like, does this thing factor? And I have a little trick I used. Yeah, I don't see the factor. All right, moving on. Moving on. Hey, next problem. Next problem. Now this one, by the time we get to 3.4, you probably wouldn't want to solve this with a quotient rule. Once we get to 3.4, it's called the chain rule. It opens everything up. So you would never have to do a quotient rule ever again. The quotient rule is not that bad, especially if you just get that little loady high, high low square the bottom way we go, and you have it down. It's not that bad. Just practice. So let's rewrite this. We have x plus 5 up top. And this negative 1 says, hey, slap all that shit down to the bottom, and we just get 2x minus 7. And then there's the problem. Now, I'm just going to run it. We're going to do this one just by looking at it. So, low, 2x minus 7, use a parenthesis, times the derivative of high. What's the derivative of x plus 5? 1. Minus high, x plus 5. Times the derivative of low. What's the slope of the line? 2x minus 7. Oops, I mean the derivative of 2x minus 7. Now we square the bottom. And we're good. Let's clean up that numerator. 2x minus 7 minus 2x minus 10. 10 all over 2x minus 7 all squared. And you see something did actually clean up just a tad bit there. So I think that our answer is going to end up being, what's that, negative 17 over 2x minus 7 all squared. There's that right. Cool. Hey, you find a numeric error in my answer, let me know via email. Sometimes I know I make them and I leave them there as little Easter egg hunts for y'all. My concepts typically aren't off, but sometimes I do make mistakes, so keep checking. All right, let's go. Let's go to this one. It's like, all right, well, let's do quotient. How dare you? Slap your hand if you even thought about doing quotient here. That is nonsense. You always want to revert back if you can. You always want to revert back. Power rule. Dude, don't do frickin' quotient rule if you can do algebra first. It makes no sense. I mean, because look how I have that thing written now. Can you follow how I got that 4/3 x to the negative first? Hope you can. Now let's take a derivative on it. Well, that 1/3 just went away. The negative 1 falls to the front. So that's going to change that to a positive 4/3. And then we're going to subtract 1. There's your answer. Or if you want to write it in all super nice. You know what I mean? Either way. Oh, did I write x's in there? Gosh dang it. Gosh dang. See, that would have been somewhere where you could have got some extra credit where I'm writing X's and I should be writing T's. Come on, dude. Come on. Come on. Gotta be better than that, huh? There it is. Whoo! Almost there. Almost there. Gosh. You're like, man, my teacher sucks. He can't even do freaking basic stuff. There it is. Oh, dang. Write H and T and then I start writing in X's. It's called muscle memory. So either one of those answers would be cool. And now we go down to our last one. Now we got this denominators all factored up. It's all factored up. Actually, you know what? Let's change this. I'm going to make that a 7. Because it doesn't matter what the freaking constant is up there. It's no big deal. Actually, shit, let's bring it back to a 1. I don't want to get crazy. Let's keep it simple. So that denominator, we need to take that thing and expand it out. All right, so let's do algebra first. I'm gonna, all right, what's that gonna be? You're gonna get an x squared minus 3 plus x cubed minus 3x. Clean it up. Let's put it in a descending order like we were taught. There we go. That's dope. That's dope. Now let's go take its derivative. Let's go find dy dx. Let's go find the derivative on y with respect to x. Or you could write that as y prime if you so desire, but getting used to Leibniz notation would be dope. So let's put it in. So the first one is low. All right, low times the derivative of high. So the derivative of the number 1 is 0. So that first term is just going to go away. Minus high, that's 1, times the derivative of low. So what's that going to be? 3x squared plus 2x minus 3. All right, that's the derivative of the bottom. And now we're going to square the bottom. Do not expand out the denominator. Do not expand out the denominator. We're about to be done with this problem. There's not much there. All we have is this negative that we need to distribute into all the pieces. We get negative 3x squared minus 2x plus 3, or you can keep it just factored with the negative on the outside if you so desire. This is just preference on my part. And here we go. There's our dy dx. And I think we got it. So there's some games, just basic rudimentary. How do you run through? How do you do your quotient rule? These are all just mid-level. These are not super challenging. Maybe not even stuff that's hard enough for your test, because we're going to end up with things and we'll start mixing it in. My hands are tied right now. I can only do so much with you. You don't know your trig yet. Once you got your trig derivatives, now it opens up. Once you know your inverse trig, it opens it up. Once you know your chain rule, once you know all the other differentiation techniques, then the game opens up. So right now, your teacher's hands are tied. I can only do so much. You're going to practice this shit in every section. Every section, you're going to have quotient, product, and you'll get better with it. So if you don't have it down right away, you will get time to get it down all through chapter 3. All right, I'll see you in the next.